All right, in a moment, I'm gonna ask you to imagine yourself in an art gallery. You're wandering around a new exhibit you've never been in before, and you see this painting. And just for a very brief second, I promise, I'm gonna pretend to be your English teacher, and I'm gonna ask you to think about what story is this image trying to tell? What's its underlining meaning or metaphor that holds it together? So I'm not exactly sure what you're thinking with us this evening, but I've had the opportunity to ask this same question to many of my peers and my teachers, and I'm fairly confident that the reoccurring answers they gave me will likely align with yours. So what did they say? Well, when shown this painting and asked that question, most often they said, is it about climate change, life, death, poison, or maybe an imaginative world, like Alice in Wonderland? And these responses make sense. I mean, if we look at the painting, we'll see very clearly a rabbit, a skeleton, and a lot of oversaturated hues. So it makes sense. But how might your perception of this image change if I told you it was made with no creative story, and instead, one of the fundamental principles of mathematics? See, most often, when we talk about math and art, they're described as two distinct pillars, but this could not be further from the truth. It is, however, because of damaging ideas like this, that many highly capable individuals constrain their potential due to preconceived ideas of creativity and critical thinking being entirely separate from one another. And that's why, in my presentation, we will be discussing the math within art, the art within math, and most importantly, the positive impacts that can occur when we focus on encouraging collaboration and the purpose and value of each subject. This fundamental change in our math culture shows us that when we approach math problems, like any creative endeavor, but with restrictions, we're able to make really valuable connections between the skills we learn in these problems and the ones we need to solve conflicts in our own daily lives. So, circling back to this painting, I will admit, it's mine. But I specifically chose this painting because, unlike most of my work, it started and ended without a plan. And as a result, I had to experiment with so much trial and error before I was satisfied with the final result. It was, however, through this process of adding and subtracting variables of my work that I discovered the same principle of balance that continuously draws me back to mathematics is also at the core of my love of fine arts. See, balance, more commonly associated with subjects like algebra, but its objective has consistently followed me through all my creative pursuits. I mean, in early stages, a painting is just a shell of its final image. If I had just shown you this picture here, would you have been able to describe the one beside it? Probably not. However, for me at least, by balancing the variables of color, contrast, and texture, the unknown reveals itself the same way X would in an equation, which I find incredibly rewarding. And although making this connection for myself has taught me so much about the possibilities in combining my passions, one of the stark contrasts I was left with through this process is about the major differences in our cultures of each subject. For instance, one thing you'll notice throughout each day of work is I change my mind a lot. And if you look really close, you'll see that almost every day I altered an aspect of the water or the lily pads. And in the setting of an art classroom, though, this is nearly considered admirable. So while I was redoing my work, I received so much positive feedback from my peers and my teachers that made me want to keep going. However, while I was covering up what are inarguably, in my mind, considered mistakes, at no point did I question my identity as an artist or think, wow, I must be really bad at painting lily pads. But what if this wasn't in an art classroom? What if this was instead in a math classroom and I wasn't a student who loves math as much as I do, and I tried really, really hard, 5, maybe even 6 times to solve a math problem with no success? I might start to question my intelligence or even begin to go as far to resent math as a whole. And unfortunately, this is exactly what has and is continuing to happen to students everywhere in the world. But it doesn't have to be like this, and it certainly doesn't have to stay like it. See, for myself, I've been privileged to spend time in the perfect environment for mathematical growth. It was surprisingly fun, very engaging, and ultimately took me by surprise. So, what was it? Well, I spent time on something called the math team. And you might hear that and cringe, which is totally okay. Most often, when I talk to people about my experiences on the math team, their perspective of what this looks like is generally limited to kids wearing pocket protectors or the early 2000s hit Mean Girls. But the biggest difference between these narrow-minded perspectives and what actually exists is how accessible the math team can be. I could go on for a very long time about this, but just to name a few, if you've ever learned a language or multiple languages, if you can play an instrument, if you like sports, textiles, jigsaw puzzles, or any puzzles, if you're interested in chess, origami, or so many other creative interests, you could greatly contribute to the future of mathematics. You might not be able to make the connection yet, hopefully by the end you will, but each of these interests provides a unique skill set that, if applied, could open countless doors to untouched innovation. I mean, just take crochet, for example. In 1997, Cornell University mathematician Diana Tamina discovered how to make a physical model of a hyperbolic plane. I know. And for those of us who don't know what that is, it's a representation of curved space that can be incredibly useful when describing things in math, science, and even how the universe works. And thanks to Diana's enthusiasm to merge her two interests, the world and all of us get to benefit from the risk that she took. Because you see through this breakthrough, we are now able to tangibly explore the unique geometry and properties of a shape that was only ever observed in theory. So I think it's pretty cool. Something else I found really surprising when I first joined the math team was that not everyone has to do the same work or even be on the same level of math literacy. What do I mean when I say that? Well, like most competitive teams, there are opportunities to take on different roles. You see, one glance at a competition booklet, and you'll very quickly recognize that 80% of the questions look like riddles, but with math vocabulary. The hard part is very rarely just solving the question, but more often deciding what you're going to solve for. And that's why we would regularly designate a student to set up or decode problems before simply passing them on to the student who is fastest at algebra. But it's roles like this, to decode and to set up, that are best suited for creative students who have a love of reading and languages. I mean, could you imagine if we could get any student to look at a word problem like a mystery novel, if we could confirm for them that at its core, math is a language, not an evil torture device, then I'm confident we'd begin to see these creative students not only find new solutions, but also help develop richer and more interesting problems to work on. But how do we do this? It's really, really easy to talk about how everything could be great, but how can we actually convince kids to care about math the way that we want them to? Well, you might be surprised to hear this, but I don't actually believe that trying to cram all of these ideas into a classroom or a textbook will be the end-all solution. And I say this because the way I think is not new. In fact, there are already many highly talented educators working endlessly to improve the math education our students are receiving, which is amazing. But it doesn't change the fact that our students who have already found success are going to be the ones who take advantage of these new opportunities, while the students who haven't will continue to feel unseen and underrepresented. And that's why the objective behind my talk is not to necessarily encourage a shift in our curriculum, but more a change in our culture around what math studies can be. I mean, this is probably fairly common, but when I talk to my peers about how they feel about math, they tell me the same thing every time, which is, I don't like math because it's hard. But we know this isn't true because we see kids do incredibly hard things all the time. So I'd like to challenge this idea with another reference from the arts, but more specifically, how film and culture have the and the impact and the influence to change the things that we choose to care about. So, if any of you have had the opportunity to speak to a high school or a high school senior about their goals for the future, I'm willing to bet that a minimum 3 of these students has told you they want to be a doctor, a surgeon, maybe even a forensic psychologist. It's a little odd, but when you consider that every single one of them has seen or heard of major shows like Grey's Anatomy and Criminal Minds, it starts to make a little bit more sense. See, these jobs are incredibly challenging and stressful, and yet many young people are willing to look past these challenges. And regardless of whether they actually pursue these careers, the point here is that they've been influenced to care about the role that people in these positions play, and as a result, they've likely started to care just a little bit more about the classes they already had to take, like biology, maybe even psych. So, am I suggesting we hire a bunch of really good-looking people to act in a series about mathematicians? Not exactly. But there are a lot of other ways we can encourage students to feel welcome, drawn to, and seen in math studies that I don't believe we've truly invested in. So let's talk about it. What are they? Well, number 1, cannot emphasize this enough, but community. Good math can be done independently, it's possible, but great math, the kind of math that changes how you think as a person, is always done in a group. And by taking some of the social aspects of sports and other extracurricular activities, I believe that we could change math culture for the better immensely. Number 2, connection. Until we show students the value in their work, they will continue to disengage. But if, as a society, we could focus on making the purpose, not the skill of doing, but the purpose of general subjects like logarithms that describe the intensity in which we hear sound, if we can make concepts like this accessible to all students, I'm confident we'd begin to see them make their own connections for themselves. And lastly, mindset. This one's pretty repetitive. We hear it a lot, but it is really, really important to talk about when we have conversations surrounding education. Because the easiest step in fixing this narrative for yourself is changing the way you talk to those around you and how you treat yourself as a person. If you are a teacher or an educator, I need you to know that your negative math mindset and personal biases can easily be passed on to the students and youth around you simply by little comments. And if you are a student, how can you hope to find success while consistently telling yourself that you're inadequate, or you miss a special puzzle piece that if you had would make everything align? The sooner you realize that the students and peers in your class you might even idolize for their genius are working incredibly hard even if you can't see it, or they've found a way that works for them, you can start to understand these are things that you can do too. And finally, when we combine these ideas of community, connection, and mindset, you'll start to understand that the only thing holding you back from reaching your potential is how much you care. And even if you have to fake it at first, I implore you to care enough about the things that you're already interested in, to take the risk of incorporating mathematical thinking or the skills it can teach you, and just watch how you develop. And so, as we move forward, it is vital that we advocate for this change in math culture, viewing it as a creative pursuit rather than a daunting challenge. Through this, we can bridge and strengthen the link between math and the arts, and through this bridge, I believe we have a unique and incredible opportunity to create a world of innovators that have the skills they need to tackle any problems that they encounter. Thank you. Thank you.